Hi guys. Hey, this is just a little video for you guys for I guess your exam. So this page it deals with systems of equations and either the substitution or the addition method, or sometimes called the elimination method. However, I don't know if you've seen it this way before, and it's the same techniques mathematically. It's just contextualized, or in the word problem, it's going to look a little different. So, I wanted to make the video for you so you'd at least have a first version of an explanation on how to do this. But I would highly recommend before you watch any of this video, um, that you go ahead and give it a shot yourself, doing parts 1, A, B, and C. And you'll notice what I'll do at the end of this video. I've already copied this entire thing and I've pasted it down here again. And for a second run at this puppy, I'm going to change the numbers, and then you guys can go to MATLAB and see if you're doing it right there as well. So, but just for now, I wanted you to at least have one go at this. And if you wanted to do the second version, even with my suggestions, you're going to do exactly the same thing as you do for what I'm showing you here in the first version. And the reason this is so important is you're going to get something very similar to this on your exam. So maybe an entire page. I'm giving away questions on your midterm, so to speak. So if you're watching this, and I will have already, you probably found this by watching or, heeding my suggestions with emails and ways to get to this page here. So great job finding your way here. And here we go. So look at number 1, and it's going to say something to the effect of, you have someone calling her Swedish aunt Anne 12 times a year, and her calls usually last between 20 minutes and 2 hours. So if that's the case, okay, I got that in my brain here. Keep going. So AT&T charges $6.01 for a 7-minute call to Sweden. Now, as soon as you see information like that, and you could write all of this down, and I'm cheating in the sense that I've already done this problem zillions of times, but notice you got a price and a certain amount of minutes. And the minutes I'm going to put here because the price that AT&T charges is going to be dependent upon, this is for AT&T. So the price that AT&T charges is going to be dependent on how long and this is going to be minutes. Notice up here, I'll say, and you'll get where it says define your variables. We're going to let X equals minutes and Y equals money. Okay. You will get on the exam points just for defining your variables. That's a couple free points right there. And if you don't, it's minus a couple points. So make sure you define your variables whenever asked in these contextualized word problems. Okay. And I don't know why that is the way it is or why that's highlighted. Let's see, get that to go away. Yeah, you know what? Since I'm having computer issues already, let's just erase that. We'll just go back. Get rid of that. Okay, so let's put that back up there. I just didn't like how that was highlighted. But as you're listening to this, so X, and we'll even put it up top here, X is going to equal minutes. Y will equal cost. You can do the same thing on the exam, and again, you'll get plus 2 points just for doing that. So hopefully you heard that enough times. So AT&T charges $6.01 for a 7-minute call. Okay, now I've already taken out this part, and that's to Sweden. Don't care what that's to. And let's see, 79 for an 8-minute call. Again, notice how I'm putting the minutes in the X spot and the money in the Y spot, because the Y depends on how long you talk for. Money depends on how long you talk. X is always the independent or the X value or the input, and the Y is always the dependent value or the output. So the output depends on the input. Money depends on the cost, or excuse me, money depends on the minutes talked, which is why it's set up that way. That is part of the test question, just to see if you can set it up right. And for now, that's gone. Now, later, well, right now, actually, they're saying write a function that represents AT&T. And if you've looked at the whole problem already, and you can always pause the video, go back, or just look at your piece of paper if you printed it out. MCI has a different scenario, so we'll worry about MCI in a little bit. But for now, AT&T looks like we have all the information down there. And what you can do then, what this is hoping you do after you define your variables, you want to get an equation that represents the linear representation. That just means you want to get the equation of a straight line, right? And for this, when this comes, I'll tell you now, you will be able to assume it's linear. So if you wanted to write a function, remember m is equal to the change in y over the change in x, or by definition, y2 minus y1 over x2 minus x1. And if I wanted to do that right off the bat, notice I'll use this formula here. Over on the left-hand side, I would say 679 minus $6.01 over 8 minutes minus 7 minutes. And if I do that, that's going to give me 78 cents for my slope of my line. Now, in the future, I'm going to ask you, what does this mean? And if you can just tell me it's 78 cents, that's incorrect. And it's close. But if I say, what does the slope mean? And this is for later just as much as now. Notice money is on top and this is minutes. So when I'm asking you, what does the slope mean in terms of the problem, I'm asking you to say something about both quantities. Don't assume that I know what you mean. You have to state it to get credit. So if I said, what does that slope mean in the context of the problem or in terms of the problem, or what does it mean to you? You should say something to the effect of, hey, for AT&T, they charge they charge 78 cents a minute. It's a ratio. It's a comparison of two quantities. So it's 78 cents per minute. That's what the slope means. Once you have that down, you can then put that in here. And all you need now, when you have the equation of a line in the other previous videos, you're always trying to find a y and, an m and a b. So we found our slope, but now you got to find your b. And one way to do that is to plug in a point. Now it doesn't matter which point. I'll take the first one. Take this one right here. But if I took that point and plugged it in for the y, just make sure you plug it in, $6.01. And that's going to, I'm trying to use colors here for you, 0.78 times my x value, which is 7, plus a b. So you see where that came from? Here's the 7, that's the x. Here's the $6.01, that's the y. So really, question A is just saying, hey, get the equation of a line for AT&T. Once you do that, now I have a calculator right next to me. 0.78 times 7 is 5.46. You're going to have $6.01 equals 5.46 plus a b. And you can go ahead and round if when you come to it for your midterm, the numbers have, more than two decimals. This one's kind of set up to be nice and neat, but if it's not nice and neat, that's okay. That's life, right? And we always, even banks, they always round their money off to the nearest cent. So you can go ahead and round. And if I wanted to solve for b, that's 601. What I do to one side, I have to do the same thing to the other side. So minus $5.46. And if I took $6.01 and subtracted off that value, you'd end up with 55 cents. So that's your B. And I know I'm running out of room here, and I also have some room in the next problem. Sorry if you can hear somebody in the background. My final equation, if I use this red value here, there's my B, and here's my M. If you write your whole equation, and we'll make it a blue equation, I guess, down here for AT&T will be y equals 0.78x plus 0.55. So make sure that you know that. And sorry, I got some sounds going on in the background. I'm not sure if you can hear them or not. So that's how you'll find in one method for finding the equation of a line. Now, one of the reasons you're going to get this problem on your exam or something similar is this next question is going to ask you, hey, find how much MCI charges. However, the tricky part here in green is that they're just giving you a rate that they charge and an actual connection fee. Now, go back to AT&T for a second. AT&T, this is the rate they charge, and this is a connection fee. In other words, when you pick up the phone, whether you're calling some, I don't know if you ever remember Miss Cleo, but Miss Cleo was oh, she charged for psychic services, and there's always a blurb at the bottom that said, hey, connection fee is this, and afterwards it's like $10 a minute. It was just crazy. So this is the connection fee for AT&T. Sorry, I'm having a hard time writing. And this is the rate, because it's a comparison of two quantities. So if I ever asked you, and I know I'm regressing back to AT&T here for a sec, but the rate that AT&T charges is not just 0.78, it's 0.78 every 1 minute. Nobody writes it though. So if I ask you for those two quantities, what's the rate that AT&T charges? 78 cents a minute. Notice that's two things. And if I said, what's the 0.55, you can say, hey, that's the flat fee to connect to begin with. So you really, this is a lot all at once. So I want to make sure you guys that's clear. So if you have questions, I'm posting this way in advance so that you can ask me in Math Lab on Monday before your test or whatever day your test is on. Now, for MCI, the reason I just went through all that is MCI just gives you straight up the rate and the flat connection fee. So for MCI is just straight up Y equals, 0.66 cents a minute plus $1.99 connection fee. There's no work associated with it, which is why this question is pretty useful in the sense that it's seeing if you recognize different ways to set up linear functions or straight lines. If you're just given the rate and the connection fee, don't work hard. Just go ahead and write it down. If you're not, like in AT&T's example over here, the blue function, then you're going to have to work and get what we did earlier. What did we do? We got the slope here, and then we used the slope to get the y-intercept there to write our final equation. And remember, this whole thing goes down to and comes back always to y equals mx plus b. All right. So if that is elusive right now, pause the video, go back, watch the whole thing all over again, and figure out how to, for part A, get the slope and the y-intercept, get an equation like here. And then for part B, if they're just handing you the slope and the y-intercept, just come over here and plug them straight in. Okay, if you're back. Now, part C is saying use an algebraic model to solve the two equations. And if we were to graph those, let's just graph them real quick so you get a good visual of what's going on. And this is going to be kind of just real quick. Notice my connection fee for MCI is almost $2, and my connection fee for the blue function is a lot lower. So I know my slope is positive at a low connection fee. So my blue graph for AT&T looks something like this. For this, y-intercept is at 0.55, and my slope is going up 78 cents a minute. Now, the other visual representation you can do, the green function, MCI, that's going to start a lot higher. Let's say it's in here at 199 a minute. That's a y-intercept as well. But it's only going up 66 cents a minute, not 78. So the slope is not as extreme. Get what I'm saying? So although you pay more up front for MCI, you charge less a minute. AT&T, you charge less up front as far as a connection fee, but then they charge more per minute, which is why the fees go up faster for the blue function here. I really need you to understand that you have two equations now, and they do cross, and that's a system of equations. So for part C, they're going to ask you, hey, find a method algebraically to solve these two equations to determine the length of a phone call that results in the same charge for both companies. And that is really right here. At that point, at this given amount of minutes, blank minutes, and some cost up here, I don't know. So that will have an X and a Y value. So you can put minutes here and money here, right? So you will have two numbers there. And at that point in time, it won't matter which company because at that amount of minutes, the cost will be the same. So that's the whole goal here is not only to recognize the content, but be able to actually take your functions and do something with them. So here's my argument. If I wanted to do that, one way to do this, now there are multiple methods. You could do it by elimination or addition, which is the same method, but just different names. But I'm also recognizing at this moment that my y function, y equals this, and well, 0.66 plus 1.99, and y also equals the other quantity. So I'm going to argue if y equals this and y equals this function over here, that you can set them equal each other, or in essence, substitute this blue function here all the way in for this y value, because they both equal y. So what that looks like is 0.78x. So this is really the substitution method, plus 0.55. And that whole thing is going to equal the green function then, the 0.66x plus 199. I can't tell you, if we were in class, and usually I can tell, physically. There's a bunch of stories, and I always like to tell a story of when I went into AT&T, and the kid actually, whoever was in there, the gentleman, was trying to tell me that my family plan, if he could sell me on a family plan, that it would be cheaper than this old grandfather plan that I had. And I typically don't do this too much, but we started writing equations, and at the end he goes, "Oh, I wouldn't touch it. Your plan is much cheaper," and he did it using the same math. So where are you going to use this in life? Right there. So at that point where you have two functions, all you have to do now is move the x's to one side. It's just an algebraic um, pr practice process, however you want to call it. So this should be what, 0.12x plus 0.55 equals my 199, which is the only thing left. Then if I subtract off 0.55, at 0.2x equals, oh, what is this? 0.44. So far, so good. Now, at that point, just divide both sides by 0.12, divide by 0.12. And you can get out your calculator if you need. All I see when I look at that is 144 divided by 12. Can you do that one? Telling me 12, you're correct. So sorry, my headset went off. At 12 minutes, those companies, notice we just determined the length of a phone call, that you have the same charge. Now, as a bonus question, I could ask you, how much is that charge? And to do that, all you'd have to do is take your 12 and plug it back in, as I do it here in my calculator. You could take this 12 and jam it right back into either function, and it wouldn't matter because they share the same point. So if I did 12 times 0.78 and hit enter, you'll get 9.36. And if I added 55 cents onto it, why, your answer should be $9.91. So that'll be the cost for either company at 12 minutes, and it wouldn't matter. Now, something to pay special attention to. Oh, I lost my train of thought. Something to pay, well, sorry, attention to is I might ask you as another question, what company would you choose? And it's kind of a blind one. Look at up top here, and I don't know if you can see where it says aunt calls her Swedish aunt 12 times a year. That doesn't tell you anything about the length of her phone call. It just says she calls a bunch. If her calls usually last 20 minutes to 2 hours, if this is a monthly charge, um, that doesn't tell you much either. 20 minutes and 2 hours though. Who would you do, or what would you tell your aunt or Ann to do? If her calls go 20 minutes to 2 hours, well, then looking at the graph, I'm after 12 minutes here, aren't I? So which company is cheaper, the blue one or the green one? After 20 minutes, doesn't matter. After 12 minutes, the cheaper function would be the green function here. So this is MCI. So if I said, which company would you choose and why? You can say at 12 minutes, and here's what I'm really looking for. At 12 minutes, it wouldn't matter. But because she usually calls after, longer, her calls last longer than 20 minutes, you can choose MCI because the cost is always going to be less. And that's not just per minute, but that's the cost including the connection fee. So this function would win. You guys understand what I'm trying to say? So again, as long as if I give you an open-ended question like that, you can defend it. Um, you should be all right, but it's got to be defended with logic and some kind of a math to support it. So again, the answer for that one, I would say, hey, MCI, I would choose MCI because it's cheaper after 12 minutes, and Ann's calls usually last after 20 minutes or longer. Okay? So please, please, please watch this again. Make sure you can recreate this. And at some point, you'll know that you're getting it when you don't have to look or refer back to this video. So what I was going to do in here for you is just get you set up. If you wanted to do another problem, you can come in here if you want and just change the numbers. Now, if you change the numbers, instead of $6 for 7 minutes, why don't you make it $8.32 for a 9-minute call? Right, there's your first point. And then to Sweden, we'll say maybe that's $5 flat for a $5 for 6-minute call. And I'm just changing the numbers so the problem changes. And then you can do MCI charges 66 minutes, 66 cents, let's say 43 cents for a call plus a buck 23. So if you change the function, or the problem with the numbers, you can go through the whole process again. Remember how we got started for AT&T? We did y2 minus y1, and I'll stop here in a second here, over x2 minus x1. But the process is exactly the same as I'll say, hey, 6 minus 9 over 5 minus 832. Let's see if that's going to make sense. That's going to give me a negative number. So already, and just because no, that's fine. So if you do that, you're going to get -3 on the top and -3.32 on the bottom. If I do that calculation, and again, I made these numbers up out of my head. I'm just talking as I'm making this video, but 3 divided by 3.32 is going to be a negative divided by a negative is a positive. So you're going to have 0.90361. So instead of 0.90361, what I'll do is I'll round that up. 0.91. Oh no, 0.90 is fine. So that just means, if I'm rounding correctly, my 0.903 would just round to 0.90. Put that over 1. And if I said, what does that mean? Oh, that's going to mean it cost me 90 cents a minute for AT&T, and label everything. And again, don't forget, define your variables. X equals minutes, Y equals cost. Dollars. You can do it that way. Because that'll get you, again, a couple free points. This whole thing, I think, would be worth 6 points if you were to see it on a test, and 6 points, more so than the normal points. So make sure you can do this, and I'm stopping there, but your function looks like this now, 0.90x plus a b, and you can keep going. Now you need to find the b. Well, I guess I can keep going. For MCI, just look real quick. MCI now charges 43 cents a minute plus $1.23 flat connection fee. So MCI is a lot faster because they just give you, again, the slope and the y-intercept, or the rate and the connection fee. But there's almost your two functions. I'll leave it to you to get the b, and then you can go through and set the two equations equal to each other, like we just talked about. You'll have 0.90x plus whatever you find here. You have to get that, and that's going to equal 0.43x. Um, let's see, did they say, yeah, plus, well, this needs to be a plus, sloppy plus 123. Okay, once you do that, you can get the solution the same way as earlier. But really, if you're watching it and you've made it this far, fantastic job. Make sure you know how to do this without help, and it will really, hint, help you for the exam. Okay, good luck. If you need questions, I'll be in the math lab.